Hello, in this video, I'm going to show an overview of the basic features of Rhino. It's aimed at people who want to learn lands design, but they have never seen Rhino before. So we will cover the most important tools. This is the summary of the topics we will see in this tutorial. I will start by the viewports, toolbars, and panels in the Rhino interface, as well as the basic zoom options. Then, I will explain which are the different geometry types available in Rhino, and how to customize the different display modes. We will see some of the Osnap options that will be useful for modeling in 2D and 3D, including the Gumball. Then, I will show some of the tools to create 2D geometry, surfaces, solids, meshes, and some generic editing tools to work with these geometry types. I will show how to create blocks, the basic visibility and lock commands, show how to control the construction plane position, and we'll finish with the basic features of the Layer Manager. Let's get started. So the first thing we see when we open Rhino is that the model space is divided in 4 viewports. One for the top, the perspective, front, and right view. If we double-click on the title of any viewport, we will maximize it. If we double-click again, we will go back to the 4-view layout. If we maximize one of the views again, we can change from one view to the other by clicking on the viewport tabs beneath the viewports. We can change the view by clicking on the arrow of the viewport title, Set View, and selecting any other view projection. All Rhino tools and commands can be accessed from different locations. You'll find the main toolbar on the right-hand side, containing the most important creation and editing tools in Rhino. On the standard toolbar, you'll find different tabs, each belonging to a specific topic. As you switch tabs, the main toolbar on the side adjusts dynamically to show related commands. For this tutorial, we will stick to the standard toolbar. There are toolbars collapsed within certain icons. If you click and hold any of the icons with a triangle at the bottom right, you can access the related toolbar and drag it to make it float on top of the interface. Drag it by the purple title bar and dock it to the side of the standard toolbar. To make it into a floating toolbar again, drag it by the cross cursor back onto the interface. To dock it alongside other tabs, we need to drag it from its tab and drop it in the desired position. In this case, we will just close it. To load other toolbars, simply right-click on the gray area, Show Toolbar. You'll find the list of available toolbars for Rhino and for its loaded plugins. You can check any toolbar to have it pop open. All Rhino commands are also available from the menus. You'll find all the commands related to curves in the Curve menu. Same thing for surfaces, solids, meshes, and so on. Let's talk about panels. By default, we will see the Object Properties panel docked to the right of the interface. From the Panels menu, we can open other panels, such as the Layers or Materials panel. We can have them float, or we can dock them to the side of the interface, underneath other docked panels. We can organize them by tabs by dragging them by their title and dropping it to the side of other docked panels. By right-clicking on the gray area next to the title of the panels, we can open other panels in the list. Check and uncheck to toggle their visibility. For this tutorial, we will work with the Properties and Layers panel only. Let's take a quick look at the command line. You can access all Rhino commands and its options by directly typing the command name and pressing Enter. The most important navigation tools are the zoom commands. If we right-click in the perspective view, we will rotate the view. Instead, right-clicking on the top or any other parallel view will pan the view. If we have an object in the scene, for example, a box, and we select it, we can run the Zoom Selected command, which will center the object in the view frame and make it easier to orbit around it. If we right-click on the same icon, we will zoom select in all 4 viewports. If we have several objects, for example, let me copy this box a few times. We can run the Zoom Extends command in the current viewport, or right-click to Zoom Extends in all 4 views. This is very useful to locate all geometry in the model. Let's take a look at the different object types available in Rhino. Here we have a few drafting objects, such as hatches, dimensions, and text, available from the Dimension menu or the Drafting tab. If we select one of them, we can modify their features in the corresponding page of the Object Properties panel. We can check the object type or change its attributes, such as the layer, display color, and so forth. For example, we can draw a dimension from here to this point. We can do the same with a hatch. Check the object type as well as with a text object. Rhino also has curves, which can be open or closed. In the main toolbar, we'll find all icons that allow us to create curves, lines, arcs, ellipses, rectangles, and so forth. There are also surfaces which can be curved or planar. Here we'll find all the commands to create this kind of object. Joining multiple surfaces together brings us to build polysurfaces, in this case an open polysurface. We can verify the object type in the Properties panel. We can also create single points or multiple points with the point command. We can create extrusions and close polysurfaces. In the main toolbar, you'll find all the commands needed to create primitives and other solid operations. We can create closed surfaces such as the sphere or the ellipsoid. Finally, we have meshes, a polygon-type geometry. This is the toolbar to create and work with meshes. Display modes are different ways of visualizing geometry in the viewports in Rhino. Click on the arrow of the viewport title to see the current display mode. We can switch to wireframe, rendered, ghosted, and so on. For now, let's just set it to shaded. To edit the display mode settings, let's open the display panel. Here we can change a few options. For example, uncheck the ISO curve visibility or change the background color into a solid color. By clicking on the Edit button at the bottom of the panel, we can access the more advanced options. We can change many different settings and details. When a setting is in blue, it means that it's been modified. We can restart the defaults by clicking on this icon. Now let's take a look at the Osnap options that we can find at the bottom of the interface. Osnaps allow us to draw with precision. They can be enabled by clicking on this button. They let us reference points on existing geometry to create new geometry at a precise location. For example, we can draw a line from the endpoint of the rectangle to the endpoint of this line, or from the middle of this rectangle and draw a perpendicular line to the ellipse. Here we have the grid snap. It forces us to draw at the intersection points of the grid. The ortho option forces us to draw in the XY direction. Smart Track is another interesting tool. It creates apparent intersection lines that serve as reference for drawing. For example, we can draw a line that follows the segment of the rectangle and goes all the way to this endpoint. Once a gray point appears, it traces a projection line that allows us to reference other points, allowing us to find intersections, perpendiculars on the existing geometry. Project is an important modeling aid. When enabled, anything we draw will be projected onto the construction plane, meaning the grid. For example, we can draw a line by projecting the endpoints of the surface onto the plane. Then, do the same for the second point of the line. The line will be located on the XY plane. If Project is disabled and we build the same line, it'll be located exactly at the endpoint of the surface above the XY plane. A very useful widget for modeling is the Gumball. When enabled, it will appear at the center of the object once selected. The different icons allow us to apply various transformations on the selected object. We can enable it from the modeling aid bar. For example, we can use it to move the object in any of the 3 directions. If we click on the arrow, we can enter a specific distance to move the object to. We can do the same with the arcs, which allow us to rotate the object, or click inside to rotate it to a certain angle. If we click on the sphere, we can extrude the object, giving it a certain thickness. The squares allow us to scale the object in one direction. A small trick: try dragging an arrow while holding down the Alt key. You'll make a copy of the object. If you right-click on the Gumball down by the modeling aids, you'll be able to access and change the Gumball settings. Let's get modeling. We'll start with 2D geometry. Go over to the top viewport. At the top of the main toolbar, you'll find the main commands to create 2D geometry. We'll run the control point curve command and start placing points on the grid. Once done, we can select the curve and see the control points used to generate it. Moving these around will alter and let us modify the shape of the curve. We can draw a polyline, placing a first point, and always following the instructions on the command line. This is true for all commands. We can define the next point by clicking on any position on the grid, or simply type a specific length and then define the direction of the segment. If we disable ortho, we'll be able to define any direction. Let's enable it again. From the command line, we can switch to arc mode. Then, back to line, and close it using the Close option in the command line. We can verify in the Properties panel that we have obtained a closed curve. In the case of the rectangle command, we can define it by placing 2 opposite corners. If we right-click to repeat the command, we can use the 3-point option in the command line to define a different orientation for the rectangle. In the case of a circle, we can snap to the center of this existing circle and define the size by diameter or radius. Feel free to explore these commands to create lines, circles, arcs, polygons, and so forth, with all their different options. Let's go through some of the tools for editing curves. Here we'll find the most useful commands. For example, fillet, chamfer, symmetry, rebuild, and many more. Let's check a few of these commands. We'll start with the fillet command. Run the command, then select the first curve to fillet, this segment of the polyline, for instance. In the command line, we define the radius of the fillet. Let's say 1 meter, and finally, we can click on the second segment. The fillet is performed while keeping the object as a closed curve. Let's now run the offset command. We'll select the same curve. In the command line, we'll specify the distance. Let's say 0.5 meters. And finally, define the direction of the offset. In this section, we'll focus on tools to work with surfaces. Here you'll find several commands to generate surfaces. For example, you can create a rectangular surface from corner to corner. If you have some planar curves, you can use the planar surface command. We can try the option to create surfaces from 3 or 4 corners. You can also create more complex shapes, such as this one. Let's delete it first and show you how to use commands such as the loft command. We'll run the command and make sure to select curves or sections from the same side. Hit Enter and simply leave the default options in the dialog box. Click OK, and now the loft is created. We can turn control points on by selecting the surface and clicking on this icon. Pushing and pulling these will modify the shape of the surface in the same way it does for curves. Here you'll find many tools to edit surfaces, such as rebuild, symmetry, fillet, and so forth. We'll take a look at the tools to work with watertight solids. Under the box icon, you'll find some of the commands to create primitives such as cylinders, cones, or pyramids. Run any of these commands and make sure to follow the instructions in the command line. Don't forget to check the available options. For example, a box is basically an extrusion of a rectangle in the vertical axis, or a sphere which can be created from different points. We will generate it from the center and type here the radius. Under this icon, we'll find the tools to edit solids. For instance, we can run a Boolean union. As long as the two objects intersect, let's take these as an example, the results will be a closed, single poly surface. Using the same logic, we can run a Boolean difference operation. We need two closed, intersecting volumes. Let's run the command, select the first object that we want to keep, press Enter, and then the volume that we want to subtract from the original one. And there we go. In the same toolbar, we'll find other useful commands for editing solids such as Move Edge. We can run it, select an edge, pick a point, and then move to another location. We can also hold down Ctrl and Shift while clicking on an edge and move it as well. Or hold down Ctrl and Shift to select a face. And again, push and pull with a gumball. Feel free to explore the rest of the solid commands in this toolbar. To work with meshes, click and hold on this icon in the main toolbar. You'll find the main tools to work with this object type. The Mesh command allows you to obtain a mesh from a poly surface. We can click on this icon, select the blue sphere, and use the slider to define the level of detail of the mesh. The mesh will be created on top of the original sphere. In the Mesh toolbar, you'll find similar commands to those of the solid tools. For instance, you'll find the Boolean tools specific to meshes. In this section, we'll run by the transform tools that are useful to edit any kind of geometry. For instance, we can create a surface, change to shaded mode, and we'll also create a circle. We'll run the trim command and use the circle as a cutting object. Hit enter and click on the side of the surface that we want to delete. Another useful command is the split command, similar to trim. Run it, select the surface, and select the isocurve option in the command line. Now, split the surface with its own isocurve. We end up with 3 surfaces as opposed to 1 object. We can change the color of the middle one to, say, red, to make the change obvious. We can also split a curve with points. We'll run the split command again. We'll click on the points option in the command line, select the curve, click at the intersecting points of the surface with the circle. Make sure the Intersect Osnap is enabled for this. As a result, I get 2 distinct curves. I will now undo the move, select both curves. In the Properties panel, you can see the selection. Now you can join it back together with the join command, so it becomes a closed polycurve. With the same command, you can join the surfaces back into a single object. If you explode it, you'll obtain again 3 separate surfaces. A similar thing happens when you create a box, which is basically a closed extrusion or poly surface. If you explode it, you'll obtain 6 separate surfaces. Selecting and joining them back together will convert it into a closed solid or poly surface. I'll change this back to red. Another useful option is the group command. We can select the 3 surfaces and group them so it'll be easier to select in just one click. To access each surface individually again, I can run the ungroup command. Here's the icon to turn control points on. If we select a curve, a single curve, control points will automatically be enabled. However, when I select multiple objects, I do need to click on this icon to enable them on all of my selection. Surface and curve control points. Next, we will look at common transformations such as moving, copying, rotating, scaling, mirroring, and so forth. Let's start with the array command. I'll select the box as the object to array. We'll define the number of objects to repeat in all three directions. Let's say an array of 4 by 4 by 6. So I'll define the starting point, and then the spacing in the X, Y direction, to end the spacing in the Z direction. Hit Enter and check the result of the array. Let's take a look at the scale commands. Let's start with Scale 3D. It will scale the object in all three directions. Scale 2D scales the object in two directions only. In this case, X and Y. Finally, Scale 1D allows you to select the object and scale it in a linear direction. Under this icon, we'll find some of the analysis tools available in Rhino. For example, we can analyze the direction of a surface to see which face is the front face. If we click on the surface, we can flip its direction. This is important when we draw some of the lens elements that are dependent of this setting. In this section, we will talk about the block command. It allows us to create block definitions. So we have these two objects, and we want to convert it into a block. We can run the command, select the geometry we want to include in the definition, and press Enter. Now define the base point and give it a name. If we delete the block definition, we can always go to File, Insert, and insert the block again. We can do this as many times as we want. We can also copy the block and have different instances of the same block definition. We can double-click on one of the instances and edit the block definition. The rest of the geometry is grayed out, allowing you to edit the block only. We can even add geometry. For example, let's say a sphere. Once we hit the OK button, the other block instances will update with all of the changes made. If we select any of these blocks and explode it, it will break into its distinct parts. Now we'll walk through the visibility and lock commands. If we have an object, let's say a box, and we want to hide it, we just need to select it and click on the light bulb icon in the standard toolbar. If we right-click on the same icon or click on this one, the objects will show up in the view again. If we have several objects in the model, let's copy this box around, and we'd like to work on this one only, we can hide the rest by using the isolate command. For this, I'll select the object, then open the visibility toolbar and click on this icon. Right-clicking on the light bulb icon will bring all hidden objects back onto the screen. In a similar way, we can freeze objects by selecting them and clicking on the lock icon, again in the standard toolbar. The object will be grayed out, so we know we can no longer select it. Right-clicking on the lock icon, or this one, will unlock all geometry. Let's take a look at the construction plane options, which we'll find inside this toolbar. Right now, we have the construction plane at the 0 elevation. The F7 button can toggle the grid visibility, giving us feedback of the construction plane position. In this toolbar, we can find options to change its position and orientation. For example, we can change the elevation, we can align the construction plane to a surface, selecting this surface, defining here the origin of the construction plane, and a second point for the x-axis. Any new objects I draw will now be located on this plane. If you want to reset the construction plane, click on the C-plane icon. Click on the World option in the command line, and then Top. Let's now take a look at the Layer Manager. It will help us organize the model in different layers. Having full control of the object's visibility, display, and printing attributes. As you can see, we already have a few layers created. We can show and hide the geometry inside each layer by clicking on the light bulb icon next to the layer name. By clicking on the lock icon, we'll lock the geometry so it stays visible, yet not modifiable. The color box allows us to change the color for all objects in that layer. Then there's the material type, line type, print color, print width. The icon next to the layer name indicates the current layer. So all the objects that we draw will now be placed inside this layer. We can change the current layer by clicking on the column next to the layer name. We can create new layers by clicking on this icon. The new layer with this icon, and the sublayer with the one besides. It'll be created under the selected layer. The lock and visibility settings of the sublayers now depend on the parent layer. If you hide the parent layer, any objects in sublayers will be hidden as well. We can detach this layer from its parent by clicking on this icon. We can convert it back into a sublayer by selecting and dragging it underneath the parent layer again. We can delete any layers by clicking on the cross button. If there had been geometry inside that layer, a warning pops up to let us know. You'll find other settings to work with layers in the layer panel, such as filters and other tools that will be explained in a more advanced tutorial. It's worth mentioning that LAN's different elements can be automatically configured to be placed in different layers according to their object type. This is something we will see in a following tutorial. Thank you for watching.